Hello, you're welcome back. Okay, so we are still looking at the equality of complex number, and I said that okay, two complex numbers are said to be equal if only their imaginary parts are equal, and of course their real parts are equal. For example, okay, now if I say that this complex number is standard form, which of course is x plus yi is equal to, all right, 4 plus 2i. So it simply means that the real part x of the left hand side of the equation is equal to the real part of the right hand side. So s is equal to 4. And at the same time, the imaginary part, yi, okay, yi of course is equal to 2i, in which I is a common factor at both sides of the equation to cancel out. So that gives me y to be equal to 2. So this can actually help us to solve equation of complex numbers. Okay, so I'm gonna bring some example. Okay, so the question goes like this. So determine the real numbers x and y. Determine the real numbers x and y. Okay, in the following equation. Now, so what are my equations? So I have number one part, number one equation. I have x minus 2yi is equal to 10i. All right, then number two of the equation, I'm looking at x plus y. Okay, then plus bracket open x minus y multiplied by I, okay, is equal to 4 plus 3i. Okay, then the last but not the least, number three, I'm having x plus 2yi. Okay, x plus 2yi, okay, equal to I plus bracket open minus 2 plus 5i. Okay, so now let's do this. So invariably now I will have to equate solution. Let me start with number one. So if these complex numbers are equal, that means the real part at the left hand side should be equal to the real part at the right hand side. So invariably x is the real part at the left hand side. Now the real part at the right hand side unfortunately is 0. Okay, there's no real part, so it's 0. That is x is equal to 0 now. And let's now compare. Minus 2yi, that is the imaginary part, should be equal to 10, is equal to 10i. Okay, so from here now I can simply get my y to be equal to 10i. Okay, of course divided by minus 2. Okay, minus 2i. I cancels I, right? So you're having minus 10 all over 2. That's gonna give me minus 5. So s is equal to 0, y is equal to 5. Number 2, let's do the same comparison. Now number 2, x plus y, okay, these are the real part of this complex number because they don't have imaginary unit attached to them, right? So invariably now I can simply say that x plus y, okay, is equal to 4. So I'll call this equation 1. Okay, because it has two variables. Then, of course, the imaginary part, the coefficient of imaginary part is s minus y, is equal to the coefficient of the imaginary part at the right-hand side, which is 3. So x minus y is equal to 3. So I'll call this equation 2. So I can solve this simply by eliminations. I'll have to subtract equation 1. I'll do equation 1 minus equation 2, okay? So s minus s will give me 0. So s is eliminated, so I'm left with y minus minus is plus, okay? I'm left with y minus, of course, into minus y, right? Is equal to 4 minus 3. Okay, so now minus is plus, so I'm gonna have y plus y, which is 2y, okay, equal to 4 minus 3, that is 1. So y is equal to 1 all over 2. So it can actually sub to get x, okay? It can sub y into this equation invariably now from equation 1, right? Okay, if you want to get x is simply going to be equal to 4 minus y, okay? Which of course is going to be 4 minus half. Okay, so that should give me 3.5. So that is that. Okay, so now let me solve the last part of the question, last part of the equation. So I am having the real part, x, the real part. Now before I do that, I have to simplify the right hand side. So I have to open this bracket, plus into minus 2, that's going to be minus 2, plus into plus 5i, that's going to be plus 5i. Of course, if I should add this, I plus 5i gives me 6i, okay? So I'm having minus 2 plus 6i. Okay, comparing coefficient or comparing the two equations, okay? So I have s is going to be equal to 2, and of course 2y, right, is equal to 6i. So that's now y is now going to equal to 6i divided by 2i, which of course is which is 3i. So please take note of that. Okay, so that's the equality of complex number. Now the next thing we're going to be looking at now, okay, in basic operation is we're going to look at the multiplication of complex number. Now I'm going to actually illustrate this using example, okay? So example, let's look at the following question. Evaluate the following. Okay, so a part of the question I have the square root of minus 5 times the square root of minus 3. Okay, then B part of the question I'm having bracket open 3 plus the square root of minus 4, bracket close, then bracket open again, multiply by 2 minus the square root of a. Okay, now C part of the question I'm having bracket open 4 plus 2i, bracket close, then times 4 minus 2i. Okay, I think one last question. So the part of the question I'm having, bracket open. Okay. Okay. So what do I have here? 2 plus I. All right. Then 3 plus 2I. Okay. So let's solve this. So this is gonna be a solution. Let's start with the very first. So the square root of course, minus 5 times the square root of minus 3. Applying the rule of sort, okay? This is going to be equal to the square root of minus 5 times the square root of minus 3. And of course, minus 5 times minus 3 will give me plus 15, okay? So invariably now, this actually, okay, tells us that anytime you multiply two complex numbers, okay, and of course, these two complex numbers, then it will give you a real number. So minus 5 times minus 3, okay, gives you 15. The square root of 15 is actually a real number, so please take note of that. Then of course, let's now look at B part of the question. In B, I'm going to expand. So I'll start with 3. 3 multiplied by 2, I'm having 6. And of course, 3 multiplied by the minus root a. Okay, so there's going to be 3 root a. So I'll now use minus 4 to multiply. Minus 4, square root of minus 4 multiplied by 2. Okay, then of course that's going to be plus 2 the square root of minus 4, and the square root of minus 4 multiplied by um, the square root of a. Okay, so I'm going to have plus the square root of minus 4a. So of course you can express this okay, so let's look at what we have here as a product of imaginary unit. This is going to be equal to, remember, this is going to be the square root of 4 times the square root of minus 1, right? The square root of 4 is 2. 2 times 2 here is 4. So of course the square root of minus 1 is the imaginary unit. Okay, the same thing happens here. The square root of 4 is 2. Okay, and of course times the square root of a, then multiplied by the imaginary unit. So adding like terms together, okay? So these two are like terms quite well. I can add it, and of course these two are like terms. Okay, so and of course I can also add it. All right, so now let's go to the C part of the question. So I have 4 multiplied by 4, that gives me, okay, now the C part of the question. Look at these two brackets. You notice something about them, okay? They have the same expression, but the difference is that, okay, they are connected by opposite side. One is having plus and the other one is having minus. This is what is called difference of two square in mathematics, right? Anytime you see such expression, is called difference of two square. So you don't need to expand that particular expression, okay? You don't need to go through the trouble of expanding it. It's simply difference of two square. So the only way to expand this is simply take the very first number there, square it. That's going to be 4 square. Then minus the square of the second number. That's going to be 2i all square. Okay, so 4 square, of course, we know is 16. Then minus 2 square is 4. Then times I square. Already we know that I square is minus 1, okay? So I'm having minus 1 times minus 4. That gives me plus 4. Of course, I square is minus 1, you know that already, okay? So adding this together, that's gonna give me 20. So I hope that is well understood. All right, now D part of the question. This one I can expand. 2 times 3 is 6. 2 times 2, here I'm having 4i. I mean for I. Then I multiplied by 3, I having 3i. I multiplied by 2i, so I'm having 2i squared. Collecting like terms, 4i plus 3i, that's 7i. So I'm having 6 plus 7i. Now, you know, I squared is minus 1. So minus 1 multiplied by 2, I'm having minus 1, okay? This is going to be minus 1. So adding 6 minus 2, okay? Of course, minus 1 multiplied by 2, that's minus 2. Pardon me. Then collecting like term, 6 minus 2, that's going to give me 4. So my final answer is 4 plus 7i. Okay, so that is multiplication and complex number. Let's now look at division and complex number. Okay. Okay, so to illustrate this, I will also use example. Okay, so let's look at example. So the question goes like this. Express the following quotient in standard form. Express the following in standard form. Okay, so a part of the question now. I have 1 all over 3i minus 5. B part of the question. I have 1 minus I divided by 1 plus I. C part of the question. I have 3 plus 4i, then divided by 2i. Okay, solution. Let's solve this. Alright, so now we have to solve this, and at the same time we have to express our answer in a standard form. Now, the way you actually divide complex number, or the way you simplify the division of complex number, okay, is still the same process you actually take in rationalization of sort. So invariably now all these quotients, I need to rationalize them. What am I doing? What do I mean by rationalizing them? The denominator of this fraction actually contains a complex number, okay? So I have to rationalizing this fraction is the same as removing the complex number in the denominator of these fractions. So I'm starting with a. So if I'm being given 1 all over 3i minus 5. So the only way I will simplify this division is to rationalize. And how do I do that? I will have to multiply the numerator and the denominator, okay, by the conjugate of the denominator. What do I mean the conjugate of a number, okay? Anytime you have an expression, a binomial expression is an expression that is made up of just two terms, okay, connected either by plus or minus. All right. So the conjugate of such an expression is always, okay, of this s plus y. The conjugate of s plus y is s minus y. Okay. And of course, if it was s minus y, the conjugate is going to be equal to s plus y. So that's the conjugate. So the same expression, but you have to change the sign that is connecting them. Okay, so in this case, the conjugate of this denominator is 3i plus 5. So I'm multiplying the numerator by the conjugate, which of course is 3i plus 5. Then I divide by whatever I do to the numerator, I also have to do to the denominator. Okay, so the denominator is still multiplied by the conjugate, which of course is 3i plus 5. Of course, 1 multiplied by 3i plus 5 is still going to give me 3i plus 5. Now, looking at this at this denominator, okay? Look at these two brackets in the denominator. You discover that this is difference of 2 square. Remember, I've already told you that once you have this, it's called difference of 2 square. So to expand that, what you will have is going to be equal to, okay, 3i all square, 3i all square, then minus 5 square. So let's finalize that. So I'm having 3i plus 5, then divided by 3i square. You know what that is going to be? That's going to be 9. Then of course I square, you know that I square is minus 1. Okay, 5 square having 25. So this is going to be 3i plus 5, then divided by minus 9 minus 25. That's going to give me minus 34. Okay, so that's my answer, but I have to put this in a standard form. Remember, standard form, I have to separate the real part and the imaginary part, okay? So that means I have to separate this fraction. So I'm going to divide the real part, okay, by the separately. Remember, this is 3i plus 5 is all divided by minus 34. So I want to separate the division. So I'm going to have the real part, okay? That's going to be 4 divided by minus 30. Please pardon me, 5 divided by minus 35. That's going to be minus 5 all over 35, 34. Then minus 3i, okay, divided by 34. So the standard form. This is the real part, and this is the imaginary part. Okay, so B part of the question. All right, what am I having? Okay, this time around I'm having 1 minus I. So I have to multiply by the conjugate of the denominator. The conjugate of the denominator is 1 minus I, okay, because the denominator is 1 plus I. So I have to multiply by 1 minus I. Then I still multiply the denominator, which of course is 1 plus I, by 1 minus I. Okay, of course, the numerator here I'm expanding. 1 times 1 is 1. 1 multiplied by minus I is minus I. Minus I multiplied by 1 is minus I. Then minus I times minus I is going to be minus I squared. Then divided by difference of 2 squared, that's 1 squared minus I squared. Okay? Alright, so now let's do this. So this is going to be equal to, of course, I squared is minus 1. You should know that already. So 1 minus 1 is 0. Okay? So I'm left with minus I. That's going to give me minus 2I. Then divided by, I have 1 square. 1 square is 1. Minus I square is minus 1. Okay, so I have minus 1 times minus. That's going to be plus 1. So what I'm having in this denominator is 1 plus 1, which is 2. So of course, minus 2 divided by 2, that will give me I. Okay, so of course, in standard form, it's simply 0 plus I. Okay, so then of course, the last but not the least, I'm having 3 plus 4I divided by 2I, okay? So in this case now, you know what I would do. There's no conjugate, so I'm just going to multiply by that complex number. Okay, so I multiply 3 plus 4I by the complex number, just the complex number, right? Which of course is 2I. Then I multiply the 2I by 2I. Okay, so let's expand this. 2I multiplied by